Ask 10 engineers what software architecture is and you'll get 10 diagrams. That's the trap. Architecture isn't the picture, it's the set of decisions underneath it, the ones that are ruinously expensive to reverse once teams have built on them. This section is about what those decisions actually are, and the one law that governs every single one. 4 things taken together are the architecture, the structure, how the system is partitioned, microservices or layered or event-driven, the characteristics it must support, the ilities, availability, scalability, performance, the success criteria that have nothing to do with what the system does and everything to do with how well it does it, the architecture decisions, the rules that constrain how the thing gets built, and the design principles, guidelines, not hard rules, where you trust teams to choose well. Notice what's not on the list, the framework, the class names, the wiring. Those are design. Architecture is the part that's costly to change. Here is the first law of software architecture, and you should tattoo it somewhere. Everything in software architecture is a trade-off. Everything. If you think you found a decision that isn't a trade-off, a free lunch, a clean win, you simply haven't spotted the trade-off yet. Keep looking, it's there. This reframes the whole job. You are not hunting for the right answer, because there usually isn't one. You're choosing which set of downsides you can live with. Make it concrete. A service needs to call another. Do it synchronously and the code is dead simple. You call, you wait, you get a result. Errors come straight back. But you've coupled their availability. If the Kali is slow or down, your caller is slow or down too. Go asynchronous and you buy responsiveness, and you decouple the two services uptime. But now you've signed up for message brokers, error handling that happens out of band, and a system that's genuinely harder to reason about. Neither is correct. Each buys something and bills you for it. That's the law in one picture. And there's a corollary that matters even more in practice. Why you made a decision outlasts how you implemented it. The implementation will get refactored, replaced, ported to a new framework, fine. But the reasoning, the trade-off you accepted and the context you accepted it in, is the thing future engineers need and almost never have. So when you record a decision, lead with the why. The how is recoverable from the code. The why, once it's lost, is gone, and someone will fix your deliberate choice without ever knowing it was one. So what does an architect actually do all day? Not draw diagrams. The real job is making and guiding architecture decisions, and then continually analyzing whether the architecture still holds as the system and the business evolve. A decision isn't a suggestion. It sets a constraint or a guideline that the development teams build within. We communicate between services only through this messaging layer is a constraint. Prefer composition here is a guideline. Either way, the architect's output is the boundary teams operate inside, not the lines of a UML chart. Now, how does one person stay credible across that whole surface? Not by knowing everything. Picture your knowledge as a pyramid. At the top, the things you know and can act on directly. Below that, much wider, the things you don't know, you've heard of the tool, you know roughly what it's for, you could learn it. And underneath, the vast base, the things you don't know. A developer's value lies in that top tier, technical depth. An architect deliberately trades some of that depth for breadth, pushing the line down into the middle band, turning unknown unknowns into known unknowns. The value isn't knowing every detail of every option. It's knowing what's possible and what each option would cost you. This is a hard pivot for senior engineers, because depth is exactly what got you here, and depth is what gets rewarded right up until this role. But the architect who insists on staying the deepest expert in the room becomes the bottleneck. And worse, defaults every decision toward the handful of things they happen to know deeply. Breadth is what lets you weigh 5 options, fairly instead of forcing the one you're fluent in. You'll feel the depth erode. That's not decay, that's the trade you're making on purpose. Which sets up what's genuinely expected of the role, and it's a wide list. Make decisions and keep analyzing the architecture as reality shifts. Stay current technically, you have to keep moving even as your depth narrows. Ensure teams actually comply with the decisions, because a constraint nobody follows isn't a constraint. Understand the business domain well enough that your trade-offs serve it. And then the part nobody warns you about: interpersonal skill and organizational politics. Most architecture decisions fail not on the technical merits, but in the room where they are sold. You cannot decide for people who won't follow you. Carry this away. Architecture is structure plus the characteristics it must support, the decisions and the principles, the expensive-to-change parts. The first law: everything is a trade-off, and if you can't see it, look harder. Record the why, not just the how. Your job is making and guiding decisions, and analyzing them forever, each one a constraint or guideline on the teams. Trade depth for breadth on purpose. And remember, the decision is only real once people follow it. Next, we turn that lens on the architecture characteristics themselves, the ilities you're actually trading between.